Welcome, algebra students, to lesson 7.4 on polygons, beginning on page 211 and going through 218. We begin with vocabulary. First, a polygon. A polygon is a closed plane figure formed by 3 or more line segments. A convex polygon is a polygon where each interior angle of that polygon is less than 180 degrees. A non-convex polygon is the situation where if a polygon has one or more reflex angles, it is a non-convex polygon. So just to illustrate, here we have a convex polygon. It's not a regular hexagon, it's more elongated, but it's all convex because each of these interior angles right here are less than 180. So here's those interior angles. Each are less than 180. Here is a non-convex polygon because when you have regular angles here that are less than 180, but this angle on the inside is greater than 180, and that's what we call a reflex angle. Therefore, this reflex angle makes this polygon non-convex. Then a regular polygon would have equal sides and equal angles. On page 211, you have all of the most common polygons listed and with their corresponding number of sides. So it is in our best interest to just copy these all down. And I just went ahead and did that. A triangle is 3-sided, quadrilateral is 4-sided, pentagon is 5-sided, hexagon is 6-sided, octagon is 8-sided, decagon is 10-sided, and dodecagon is 12-sided. Sometimes you don't know how many sides. These are common. There's also polygons that have other numbered sides. So n sides, we would call an n-gon. For example, if there's 17 sides, we would call it a 17-gon because they don't have one of these fancy little names. So moving on, we're going to go to the first property of common polygons, and you find that on 213. Basically, the sum of the interior angles of an n-sided polygon is basically this. You take the number of sides, which is n, you subtract 2, and then you take that number and multiply it by 180 degrees, and that gives us the sum, the angle sum of whatever polygon it is, no matter what sides. So, for example, if you had a triangle, you would put 3 here because it's 3 sides. 3 minus 2 is 1. 1 times 180 is 180. And we know the 3 angles of a triangle is 180 degrees. So as you substitute the sides here, subtract by 2. For example, the dodecagon has 12 sides. So 12 minus 2 is 10. 10 times 180. 1,800 degrees is the sum of all the 12 angles of that dodecagon. So going on to try 15 at the bottom of 213, it asks us to find the measure of angle Y in the figure. If you notice, angle Y, the polygon has 4 angles. It's 4-sided. So the first thing I'm going to do is plug that side into this formula, 4 minus 2, which is 2 times 180. So 2 times 180 is 360. Now I know all of the sides of that polygon total 360s. Therefore, if I look at it, I have a measure at angle P of 68, at angle Q 75 degrees, and then up at angle R I have the right angle symbol, which is worth 90 degrees. So at that point, angle Y is simply going to be 360, all of the angles, and I'm going to minus the 3 angles that are given. So I'm going to subtract 68, and then from that 75, and finally from that 90 degrees because of the angle sum of a polygon, that rule. Therefore, angle Y is 127 degrees. Okay, moving on to the next page, try at 16. You actually see more in the middle of the page. So in that particular figure, we have, it says in the figure, A, B, C, D, E, F is a regular hexagon. So that means if it's a regular anything, that means all the sides are equal, all the angles are equal. That's what that term regular means. So it asks us to find the measures of angle X, angle Y, and angle Z. So if you look at angle X, you see that it is one of the interior angles of that hexagon. So 6 sides, 6 minus 2 is 4. 4 times 180 is 720. I know the whole 6 sides of those angles, all 6 angles of that hexagon total 720. And angle X is one of them. So angle X is going to be 720 divided by 6, which is 120 degrees. Moving right along to angle Y. Angle Y is really just half of the angle you see at BCD. So it's half of this, because the whole thing would be another 120 because they're all equal. So I'm just going to go half of 20, which is 60 degrees. Now angle Z. There's a few steps involved here. First of all, angle ABF is equal to angle FAFB because they are the 2 base angles of that isosceles triangle formed by points A, F, and B. Okay, so I can find this angle ABF, which is 180 minus 120. So I'm getting rid of what I found here. And then I'm going to divide it by 2. So that's 60 divided by 2. So angle ABF is 30 degrees. Now angle FBC, therefore, is 120 minus that 30 degrees, which gives me 90 degrees. And now I can find angle Z. So the sum of the angles of a triangle is, of course, 180. I'm going to subtract 90, and then I'm going to subtract 60 that I found up here, and I end up with 30 degrees. Okay, there you have it. If you need to pause and rewind and listen to this once again, go ahead. If you have questions, please ask. Continuing on with try at 17. Let's see here, am I all in focus? I think so. So try at 17 states, the angle sum of the interior angles of an n-sided polygon is 1,620 degrees. Find the value of n. Okay, so I'm going to use that formula and plug 1,620 degrees into the total angle of whatever sides that is. So n minus 2 times 180 is going to be 1,620. So I'm going to first divide through by 180 to leave me with just the n minus 2. After I do that, n minus 2 is 9. And then n, as I even out sides by adding 2 to each side, n is 11. So there are 11 sides to that polygon. 11 sides is the value of n. Going on to the second property now, we will see that on page 216. But if you look at 215, you see polygons with their sides extended, and then you see the shaded parts of the exterior angles of those polygons, which is what we're going to be talking about in this property. So the sum of the exterior angles of a polygon is 360 degrees, and we prove or write that rule like exterior angle sum of a polygon. So moving right along to 18, I'm looking at that figure. It's a triangle with each side extended. And up at angle C at the top, I have that exterior angle measuring 111. And then I have an exterior angle Y that is unknown down by letter B. And then by letter A, on the exterior side, I have angle X, but on the interior, I have an angle worth 44 degrees. So my task in Triad 18 is to find the measures of angles X and Y. So angle X is rather simple because it lies on a straight line. So angle X is 180 minus the 44 because they're adjacent angles on a straight line. So 180 minus 44 is 136 degrees. Now, to find angle Y, I have to do a couple more steps. So at first I recall that angle CBA is equal to 111 minus 44 degrees because of the exterior angles of a triangle. So that's 67 degrees. Now I have some more adjacent angles on a straight line, so therefore angle Y will be 180 minus that 67 degrees, which leaves me with 113 degrees. Okay, now at the bottom of the page, Triad 19 says, find the measure of each interior angle of a regular octagon. Now I have that adjective regular. That means all the angles are equal. So therefore, each exterior angle is where I start with because those are all worth 360. So 360 divided by 8 gives me 45 degrees for all of the exterior angles. Therefore, each of the interior angles would be 180 minus 45 degrees because of the adjacent angles on a straight line. So that means it's 135 degrees. So you could sketch that out if you would like to. But if you remember exterior angles, and then once you find that, the exterior plus the interior make a straight line, which is 180, you can just find the difference, which is 135 degrees. Okay, continuing on. Top of 218 in Triad 20. So we're told here, if each interior angle of a regular n-sided polygon is 156 degrees, find the value of n. So we want to find out how many sides this regular polygon is. Regular, again, means all sides are equal. So first of all, we know the exterior angle. We need to find the exterior angle. So 180 minus the 156, which is the interior, gives us the exterior angle of 24 degrees. And at this point, I can go 24 times n, because now we're on the inside, or on the outside, 24 times n, because there's this many of them, is going to be 360. So I divide by 24 on each side, and therefore 360 divided by 24 is 15 degrees. Let me say that again, because I got my exteriors and interiors kind of flipped around. So again, we're trying to find how many sides this polygon has, and we know that the interior angles measure 156. So using their property of adjacent angles on a straight line, I'm going to take 180 minus 156 is 24. That gives me one of those exterior angles. Now, an n-sided polygon. Okay, I still don't know how many sides there are, but I know all the angles on the exterior total 360. So if one of them is 24, 24 times however many will get me to 360. Because of the exterior angle sum of a polygon, again, I divide through to get my answer. Therefore, I have n is 15. I have 15 degrees. That's wrong. There are 15 sides actually in this polygon, because that's what I was going for. Okay, so 15 sides to that thing. Alrighty. As always, stop, rewind, listen again. If you have any questions, please take time to ask. I will give you your assignment in class today. Thank you, and do good math.